perfect. So my talk is going to be short because everybody's exhausted, so am I. I know that for sure. So I'll try to make it really quick, and then you can ask probably a few questions if you have any, and we'll go for beers. So Elixir. So why the need? So you have heard a lot of interesting things about Erlang today, how powerful it is, how efficient it is, and it powers NoSQL databases, message exchanges, websites, you name it, HTTP routing layers in Heroku, everything. It's fault tolerant, it's functional, highly concurrent, and many other properties. Why do we need to do anything else? Isn't it perfect the way it is? Well, it's even also so much fun to play with. And the question that I normally have, why other people don't have as much fun as I do with Erlang. Another question, do you know why Joe prototyped Erl2? Even though nobody uses it, obviously, but why the hell did he actually try to do something like this? Well, maybe there is a valid reason to explore this area. Let's take a few examples, go through them, and see what we can do. So here we can see a standard gen server that does exactly nothing. I didn't count how many lines is that? 20, roughly? Probably, but it does exactly nothing. It's actually just from Emacs template. It's just what it generates, but I removed all the comments that it generates as well, because it blows up the whole file. It just becomes humongous, right? All right, and I'll show you an example in Elixir. This one. So it says how to start, how to initialize, nothing else. No boilerplate, just few efficient lines of code. And it does exactly the same thing, which is nothing. Great. So how about adding calls? So we need to implement a call to our gen server. How do we do that in Erlang? We take that really, really long, nice template and go and implement a handle call callback, saying what kind of call do we want to receive, how do we match on whom are we receiving from, what's our state, and do some stuff. In this case, we just reply, OK, it's good. But the journey doesn't end there. The next thing you do, you go up and add a function that does nothing more than just calling that gen server. Great. Are we done yet? Not exactly. Then we go up there and export it, because, well, you'll probably forget to do that, every now and then. I certainly know I did many times, and that caused me, I don't know, cumulative time, maybe hours and hours of work. Why the hell does that thing doesn't work? Well, I just forgot to export something, and I was relying on that. Why do I get undef? I don't know. It should just work. So how does that work in Elixir? Ta-da! This is it. So I say def call, the name of the call. That's what goes into the first element of the tuple. I mention some any state and do the same reply. I reply with OK, Edom. That's pretty much it. So what the function does, it creates the handle call callback. It creates an exported function to call into this. And it's extremely configurable. Like, for example, if you do not want to export any function that will call into this gen server, just add one more option saying export false. Or if you want to rename the function that will call into this particular handler, well, you can do so using the very same option, the export function option. And there are many other options that allow you to specify whether you want to allow this function to carry the PID or the name of the server you're calling into, or pre-specify a name that you want that function to use, so that you don't have to pass the PID or the name of the server into that function if it's a globally registered process of some kind. And this function or method, or actually it's a macro, does exactly this. So how does Elixir achieve this? How is it possible? Well, it actually does Lisp-style macros. They're simple and powerful. They only have like 3 operations, but they are just good enough to express pretty much any kind of domain-specific language. So what exactly does enable that? So one of the things that it has is that the code structures in Elixir are usually represented in very simple tuples. So for example, for an operation of 1 + 2, you'll have a tuple saying it's a plus function, and then there's a line in the module where it was used, and the arguments to that function. And that's very easy to work with. This is almost like Lisp. Not exactly, because, well, your representation of the code in the source file is different from this, but this is close enough. You don't have the complexity of Erlang AST, which is quite complex when it gets to calling, say, remote functions. You need to nest a lot of remote atom kind of things. It's just really hard to read. This is, on the other side, quite simple. It gets a little bit more complicated when you use modules that are sort of like aliases to other modules. But if you forget about this aliases part, you can see IO puts and the arguments. Pretty easy, eh? So the other thing that enables that kind of thing is quoting and unquoting. So what you can do, you can create from an expression written in a normal form, you can create an internal representation. So if you do quote 1 plus 2, you'll get how it looks like in the internal representation. And you can do so with variables. For example, in the second example, I assign a quoting of 1 plus 2 to a variable. And then I say, well, quote, unquote. So basically, I'm just passing that data into quoting thing. And I can inject that part into any code that I want. So I can surround it with different code, just around the unquote of A, and produce more code without you doing anything complex. And you can do much more. You can do things like uncoating splicing. So what that means is that instead of unquoting a list as a list, it unquotes it as sort of list arguments. So you can unquote it into a function call of a sort. So you call the function, and you unquote a list of arguments, and they become real arguments of that function. So this way you can do really interesting stuff. And this is just like in Lisp. I think it's comma et in Lisp, whoever knows Lisp, or like common Lisp in this particular case, pretty much like that. And finally, macros. So a macro is actually a very simple function. Here I'm defining a function that, a macro that actually exists in Elixir, and I think it's a little bit more complicated than this, but for the purpose of an example, this is good enough. So everybody knows the if construct. So if something, do something. And a lot of people who use, say, Ruby or similar languages, they are familiar with the construct called unless, which is the opposite of if. Well, how about if we don't have unless? How do we implement it without having any extra function calls or anything? Well, we'll write this macro called unless, which takes a condition that you want to work on. And it takes options, which is usually like a body of what do you want to do if that condition was true, or in this case, false. And you create this quoting block, which says, if not unquote condition, so we sort of inject the code that you pass to it, then unquote, what do we do in that case? So basically, I just inverted the condition. And the beauty of this is this thing happens compile time. So your code is as efficient as if it was written as if not certain condition, and the block that gets executed. So here, just an example, unless 2 less than 1, then do IO puts, everything's okay. Are you doing okay with this? So does everybody understand what macros are? No need to explain a little bit deeper? No? All right. So the idea of this is productivity. Because a lot of times we have to deal with a lot of interesting, creepy things in Erlang, like all those very old boilerplate templates, and we just have to repeat this again and again and again. And if, for example, you crafted your own new template for Gen server, which is kind of better than the original one, then you probably want to migrate your old code to your new standardized look, and this is just tedious. Why do we have to repeat ourselves so many times? Or why do we need to write parse transformations that are really, really hard to write and to get them right and to get them tested? Because they do the same thing, just from the other end. They get the code that you wrote and transform it to something else. Well, why wouldn't we just tell the system that, well, this is the thing that we want to rewrite right here, right now, and we don't need to scan the whole module. Why do we need that? So being more productive is an important goal of Elixir development. Monkey patching. So as Kevin put it today, if you're doing it, you're sick, seek help. And in Erlang, you can't really do like Ruby-style monkey patching, but what I've seen a lot, people don't like certain module, and they take it, fork it effectively, put it in their own application so it screws up further integration with other libraries, and just change a few things to their liking. That's also monkey patching, just even, actually I think it's worse than the original Ruby monkey patching, because this way you're having a totally completely independent fork, which nobody can really work with. So this is not a way to do certain things. So for example, actually this is an actual code from JSX, a Json library. What does it do? It basically matches on the type of a thing that you pass into encoding and encodes it in certain, well, not JSON right now, but in the other parts of this file, it will get to an actual JSON. But what if I actually want to add one more thing there to convert it to JSON automatically, so that I don't have to go through two passes. One is for my own data types conversions, and then through JSX conversions. What if I just want to pass the data structure in there and just get it automatically converted to JSON? Well, you're kind of out of luck with Erlang, so you'll have to fork JSX and you'll have to maintain a private fork. Or you have to have this first stage of preliminary processing. In Elixir, they're using protocols. So protocols, if you're familiar with either, say, Clojure or Smalltalk, you probably heard about them. This is like, actually, this is like Java interface in a way. So here, what we say, we have an encode, like a JSON encoder protocol, and we define what functions are there. And what do we do later? So we say JSON encoder for string is doing that particular operation. JSON encoder for integer is doing another operation. And all those implementations are actually modules. So is the protocol. So what the protocol module does, it basically does the dispatching. So it looks at the type of the thing that you passed into it and just says, okay, this goes there. So we know, like we have a module that implements it, just send it over there. Actually, it doesn't even check whether you have that module, it just sends it there. So this way, you can actually do some reasonable extensibility comparing to normal Erlang, so that the author of the original library doesn't have to think, what kind of stuff do you want to put into use when you're using that library? If the library is designed in this extensible manner, you actually shouldn't care. Well, if people want to do something weird with it, well, it's their choice, but they don't have to fork, they don't have to monkey patch or whatever. They can just use it. Another interesting thing is we finally got a sort of first-class shell. So did anyone have a problem with shell not being exactly that same Erlang that you have in Emacs? Like you can't define a module, you can define it, well, you sort of can define a record in a completely different syntax. Creating a module, forget about it, and other things. So here in the shell, you can actually define your module right away. It won't be saved to any file by default, at least. It will be just in memory. So you create that module, say its name, hello world, do something, it's automatically compiled on the fly, and you can use it right away. So it's just there. Another thing, so modules are actually programs. So if you actually read Joe's proposal about Erl 2, he was talking about sort of program structures or modules that are programs themselves. So that while you're doing an assembly of a module, I want to do some work. And in Elixir, we actually have it. So in this case, I actually do something completely unheard of in Erlang modules. So on the module level, in the module level, I assign some value to a variable, and if that variable is true, I actually print something out and define a function. So it's compile time code, just like, again, in Lisps. So this way, after I enter the module into the shell, I can see the let's do it printout, and I can see the result of the def module macro, which means, well, I just succeeded at creating a module that was defined dynamically. And sort of almost first-class records. So records are a known pain in Erlang. So there's a lot of horror stories about them. So the way Elixir handles records is actually very simple. So records are actually modules. So every record that you can define with Elixir, with the def record macro, it actually transforms into a def module with predefined functions for getting the values of your fields and setting them, and actually a few more like incrementing them and something. I think there's some list management as well. So it's actually fairly sophisticated. And if that is not enough, there are a few more interesting things about records. So for example, since record is a module, you can actually define more functions in those modules, like in this case with def record another state. So I had some fields, and then I say do, and I create more functions right there. So you can work with that record as a module, so you can work with that data by defining locally scoped functionality around the values in that record. And another thing, you can obviously match against it. So instead of using fairly expensive function calls, you can just match records and extract certain values that you need. And those are pretty efficient because it is compile time. So the idea of this is making fucking sense out of Erlang, because Erlang has been around for many years, but there's a little bit of this tradition of keeping things the way they are, even if they don't make a lot of sense. So what is Elixir? Well, Elixir is good news for all of us. It's a compiler to Beam, so it's completely interoperable with Erlang. So whenever you have another Erlang library that you want to use, well, just go and use it. It's the same damn thing. And Elixir is not exactly a new syntax, although it does have a different syntax. It is just made a compiler to Erlang. So the most important thing is not that it introduces new syntax. The tectonic shift here is that it introduces macros and all the functionality around them to Erlang. That's the most important thing there. But it also has a set of nice libraries designed sort of sometimes in a closure fashion, sometimes in a sort of Ruby-ish fashion. But what they're trying to do is to maintain a little bit more consistency in the standard library. Because we know that the standard library in Erlang is not exactly consistent. You have different naming styles, you have inconsistent module names. So that thing is trying to, again, make a little bit more sense of it. Since there is a chance to redesign a standard library just a bit, well, why not try to do it? And again, it's obviously an ambitious project, and I'm only just briefly associated with it. I'm just doing a little bit of stuff around it. So what else? Well, I ported type specifications to it about a month ago. So done, we have them. We can all love Dialyzer. I created a library called GenX. It's basically what you have seen when I was talking about very concise Gen server or Gen FSM event definitions. And actually supervisors as well, because I hate creating supervision trees in Erlang. That thing I didn't show, but believe me, it's so much easier, so much more transparent than whatever you have in Erlang. I've got a rebar plugin, so you can compile your mixed or like mixed Erlang and Elixir or just Elixir projects with rebar, so you don't have to change your toolchain, which is kind of cool. And version 0.6 is coming out. I think it actually was scheduled for yesterday, but I don't think it got released. I think something is holding up the release just a bit. But actually, right before the release, we at Spawn created auto-completion for the shell, so it's actually much more fun now to play with Elixir when you have auto-completion. And it's already merged in, so that's kind of cool. Elixir, go to elixir-lang.org if you're interested, or talk to me. I'll be around for a little bit more. And if you have any questions right now, feel free to ask them.
Data types. What is Elixir's data types like?
Same.
Exactly the same.
Exactly. Basically, the only data type that might cause you a little bit of confusion in the very beginning is what I don't remember what exactly do we call them right now because we changed a couple of names, I think. But basically, they're like Edom References. So you've seen stuff like IO, right, with capital letter. Right. So basically, those are Edoms. It's just internal representation is actually sort of a tuple, but it points, like usually the way it works, we either, like if it's an alias to some other module, you can define aliases for Edoms. It will just point to an actual Edom. So you can say, okay, the Json server library is actually like nicely capitalized Json server library. Right. Or you can use it as not pointer, like you can create a module. So that will be just an Edom, basically. When you compile, that thing just expands a little bit. So on your file system, if you have a def module, my module, so what you'll see on your file system is elixir-mymodule.beam. The reason is we can't really use dots because they interfere with how fast supported packages. Right. So we had to opt for another character. So it's a little thing, but actually when you write some Erlang code that interoperates with Elixir code, we have a Parse Transformation for Erlang code that allows you to put the dots in the name of that module, like elixir.mymodule, right? And it would just we'll just find those Edoms and rewrite them to the dashed ones.
So when you have the dots in the module names, that doesn't imply like a directory hierarchy?
No, it will just put the dashes.
Okay.
So, but this way in Elixir you can create, and actually this is just well supported, you can create nested modules, sometimes very useful. Like for example, I can create a def, like if you actually go back for my Json server example, you've probably seen the def record state, because it's kind of local to the process, right? Like to the module that implements it. So it's actually my module or my server, whatever that is. That module name is actually my server dot, or in the file system dash state. Okay. So it's actually very well isolated. But for Erlang, it's just a longer name for the module. So Erlang itself doesn't care. So that kind of plays well together. And the rest of data types, like this is still Edoms. It's just kind of funny Edoms, just for like aesthetic purposes, really. The rest?
The one that kind of caught my eye was when you're going through the protocol example, you referenced string.
Yeah.
There, and since Erlang kind of lacks a real idea of the string, I was wondering how that makes sense.
That's an interesting idea. So basically, by default, the string that you write in double quotes is actually binary, okay, which is great news. Like, I love it. If you still need a list string, you just do single quotes. Okay. So it's kind of actually nice and neat. And this kind of enforces people to use binaries, which is, I think, a great thing.
Cool, thanks.
Any other questions?
Is this used at all, or is this just like mainly research?
I think we're the first company using it to develop an actual product. Because we basically converted a lot of our stuff in the past 2 months because I think we're becoming the very first. We still don't have it in production, but it improved our performance basically. I'm not talking about the performance of the team, so productivity. It improved it greatly because our code is so much better now. I just cannot convey my happiness really. It's just we removed probably about 60% of the code, which was just there, and it was really at that point that code was sort of getting unmanageable. Because we tried to do stuff that really fit in macros, and we didn't have them. So that was really ugly. And now it's just so neat and tight. So I couldn't be happier. But obviously nobody deployed it to production. On the other hand, it is just still Erlang. So you compile to Erlang, and why would you care? It's not really a different language or a platform. It's usually, that's the concern when somebody develops a new language, new fancy language, and everybody's, yeah, it's kind of cool, but does it work in production? Well, yes, it did. Elixir did work 20 years in production because it is Erlang.
Do you have any performance
it's compile time. Like, I mean, there is a little bit of overhead on protocols, but it's very manageable. Basically, if you do write libraries in a similar fashion in Erlang, you'll have exactly the same penalty for dispatching the request. But since it's happening in a functional way, so you're not using any processes, that should be actually pretty good. So if you need performance, like every bit of it, then probably you don't want to use protocols. But we don't have any specific measurements of that. It's just wild guesses that, well, obviously, since we have a little bit of logic over there.
It's basically on par with just native.
Yeah, some things, you have to understand what macros generate for you. Like if you are concerned about performance, look in the source code. What does that macro do? If it creates a lot of really bad code, probably you don't want to use that macro, right? So, but if it does a good job or a reasonable job for your purposes, just go ahead and use it because it will save you tons of time. All right?
You say you compile to Beam, and on the mailing list there were a lot of discussions about that there is no actual specification for Beam, like
yeah.
Like the compiler doesn't have any problems that you see.
No, that part. Well, actually, I'll correct you a few things. So there is a specification for core Erlang. On the other hand, Elixir does not use core Erlang right now at all. It compiles to Erlang AST, which is very well documented. There are many reasons. Well, it's kind of simpler. Elixir's goal is not to change Erlang semantics really. So the way we bind variables is the very same way we do in Erlang. So if you define something in the case structure, it's available down there. So it's just easier to compile to Erlang. All the optimizations of the compiler, they still are applying to that because we don't need to do them. Erlang is doing that for us. So just that.
Do you analyze, is there any considerable impact on hot swap, stuff like that?
It's still Erlang. Basically, what you have is you have a code compiled to Erlang and an additional library that you might either use it or not, up to you, but it's just a library, right? So usually just a library of functional, sometimes not functional, primitives. So for you, it's just the very same Erlang system because what you compile to is Erlang. What you use, like those modules, are still Beam files, right? It's just still the same thing. Although I haven't done hot code upgrade in it yet, but I don't expect any problem with it. And I know Jose, he is probably not gonna screw that up either, because he is a Ruby guy basically, converted to Erlang, but he wanted something a little bit more productive and other goals that I've been mentioning. So obviously he does want to have all the features available to Elixir. And if something doesn't work, and there was a lot of cases of that ever since we joined the project, it was a very efficient process of updating it, changing the syntax. So if syntax really doesn't work out, he was very available to change the things, to make things right. Because it's still not 1.0. It's still a good time to do some radical changes if they don't really work well.
No, it's not a problem. It would be just interesting to analyze the behavior because generators typically are able to take different paths in generating code, so you won't maybe just puke out code and have to reload too much later during a hot swap. So just to have it, just to have it considered.
Oh, so you're talking more about like macro generation for upgrade procedure or something like that.
Let's discuss later maybe.
All right. So.
It would take 2 minutes.
All right. Okay. Fair enough.
It just goes into
A little bit
production.
detail, yeah. All right. Any other questions? If not, then I'll pass to some fun stuff from Tavis. I guess, yeah. I'll do exactly that.